This is my first time speaking at droidCon or any conference, so hopefully this goes really well and nothing breaks. Start off, I saw this mural in my neighborhood and it reminded me of starting out in MotionLayout. There's just a lot of pieces to it, and as you're starting to learn it, it just seems a little confusing because there's so much going on with transitions and constraint sets and everything. I'm going to be throwing you right into the middle of it, but I hope that just like this mural, you eventually see the bigger picture and how beautiful it all is and how it eventually helps you make a really vibrant, amazing Android app. So let's get into it. So what we're going to be talking about, we're going to build a complex experience with MotionLayout. I'm going to try to build on essentially just two examples throughout the entire talk. Start with little pieces at first and then get into practical examples. Along the way, I want you to be thinking of two different questions. What can MotionLayout do, and why is this useful to you and your team? So you can take those things away. So we're going to start simple. And by simple, I mean literally just a layout file with MotionLayout in it, and there's nothing else. It just has match parent, and I don't care about the schemas, they're not important. So very first thing in MotionLayout is you need to have a layout description in order to animate anything. But in order to do that, we need a motion scene file. How do we create that? Well, depending on what version of Android Studio you're running and Android Gradle plugin, you might need to do this weird workaround where you make an adders file that adds properties. You need to do this for 3.6 alpha 4 and higher. Beyond that, you need to go make a new directory called XML, and then in that XML directory you're going to make a new file, and that file is going to be called motion scene for your first motion scene file, because that makes sense. But then this weird thing happens where Android Studio makes a preference screen file because MotionLayout's not built into it yet. It doesn't know what that is. So I recommend making a template of this so you don't do this every single time you make a motion layout. So there's that. Now we have a motion scene file, so now we can go back to the layout file. We can add in the layout description. We can point at the motion scene file that we just made. Note that it's XML/motion scene, not layout. And it compiles. Great, we have a blank screen. Going great so far. So now we actually want to animate or do something useful. So we're going to add the first child to the motion scene, or motion layout. And we're going to add this child, just 100 by 100 purple square. Hope it works really well. And the app crashes at runtime. And why does this happen? It's because, like anything, you need to put some work into it, and MotionLayout requires at least one constraint set in every single motion scene file. So let's go make that. Back to the motion scene file, we add a constraint set, and all of a sudden we get this wonderful indigo screen. This does not look like the square that I was describing in the layout file, and that's because there were no constraints to it, so it's unbounded. MotionLayout behaves a little bit differently than ConstraintLayout. ConstraintLayout would not have compiled with this, whereas MotionLayout's a little bit forgiving, but also a little strange sometimes. I'm going to omit these tags from now on, just because they're just not useful to anybody. This is a little bit better now that I have constraint. Basically, I'm just constraining this square to the top of the screen, and I need to animate it in order to do something fun. So I'm going to create a second constraint. I'm going to call it the end, and these are the constraints for it. Very similar. It seems like I'm copy pasting code, and I'm going to get back to that later. I'm going to constrain this one to the bottom. In order to actually animate in a motion scene, I need to have a transition. And this transition needs some kind of start and end. So I'm going to open this up, and I'm going to add a start, and it's going to point at start, and I'm going to have end, and it points at end. Very straightforward so far. So now I need some user input, or way to have triggered this transition. So I'm going to start with an onClick and all its properties and things. So the onClick is going to target the square, which means when you click the square, that's when the animation will actually run. I'm going to specify click action will transition to end, which is going to tell MotionLayout that's going to start wherever it is in the current motion scene progress and transition to the end of the transition. So if I compile this, it works. Cool. This is also still very boring, so let's make something more complex. Back to onClick for a quick second. I just want to explore the other options that are there. So if you look at this, it says transition to end. Well, can I do transition to start? Yes, you can. But in this case, because we're starting from app start and we just started at the start transition, if you click this, it will run and do nothing because we're already at the start. So there's this, where you can have an OR operator. There are very few OR operators in MotionLayout, and this is one of them, where you can write transition to start and transition to end. This is a little verbose, so there's another operator called toggle, which does the exact same thing. Sorry. Anyway, moving on to interpolation. Those are all the options of onClick. You might have noticed that I was using easing transitions before. By default, MotionLayout uses linear, so I was cheating a little bit before. The other options of MotionLayout's interpolators are essentially just ease in, out, which is this. And there's this other one called cubic, where you can define your own Bezier cubic function. I don't have an example of this because I ran out of time creating examples, and I have a lot of them. So there's this handy website called cubicbezier.com you can go look up. And when you look at it, it looks like this, where you can play around with any kind of curve you want. Since you can't do this in Android Studio yet, you'll probably be using this tool when you're learning Bezier cubes, and eventually you'll just get them into your brain just like we all get hexadecimal codes in for colors. So, now we're done with interpolators on clicks. Now we're going to look at on swipe, the other gesture input, which is a lot more complex and a lot more fun. So, in this, I'm saying the touch anchor is going to be the square, so when I drag or on swipe on the screen, it's rendering the animation relative to the progress of the square moving through the motion scene. The touch anchor side just means which side of the view it's going to calculate the progress from, so like the top of it or the bottom. I could actually specify either in this. If you want to see a little bit more why or how that's calculated, you should go watch the other MotionLayout talk from yesterday who also did an excellent introduction and is covering things that I'm missing here. The drag direction is just going to drag down. You can obviously say drag left, drag right, drag up, drag down. And in this case, I'm just having it drag. This is what it looks like with the defaults, where on release it flings, but otherwise you can move it as fast or as slow as you want. Another thing that you can specify is on touch up stop, where it just stops. It does not fling at all. This is useful for some use cases in designs, especially with like scrolling views where you just want the user input to stop. But actually, most products want some kind of fling behavior, so this isn't really useful in many cases. The option that you probably want is decelerate. Unfortunately, it's currently buggy in MotionLayout, and it does weird things like fling when you don't mean it to and stop when you meant to fling. So they're still working on that. Now we've covered the couple major inputs. I'm going to cover adding another state. So we have a start and end with a top and bottom. I'm not going to bother going through all the constraints of those right now. I'm just going to add a middle constraint, and just to take my word for it that it's constrained to the middle of the screen. I'm going to make a transition that goes from start to middle using the same exact on-swipe gesture as I had before, and another one from middle to end. When this actually runs, you're able to fling it to the middle and release, or, really important, you can drag through. No other gesture in Android animation allows you to do this easily. This is when MotionLayout is starting to show its power. Sub-elements. This is a really fun topic that I kind of need to tangent into because it'll be important later, and I'm just trying to cover all the basics during this purple section. So sub-elements are a way to write constraints without having to rewrite everything all at once. And the way to write sub-elements is, instead of this, all I'm going to do is move these constraints into a layout sub-element. This means that if I were to have other sub-elements and derive constraints later, that I wouldn't need to overwrite all the different layout constraints. I'll show you exactly what that means, why, later. For now, just want to go through all these other sub-elements and what they do and what their properties are. There's layout, property set, transform, motion, and custom. And I'm going to have a lot of examples for a number of these. So layout, you've already seen all the examples that I have for layout properties, really. Property set covers visibility, alpha, and motion progress. So visibility and alpha are very straightforward for us. We've seen them and used them a lot in other animations, but visibility mode is a brand new thing. It's only for motion layout, as well as motion progress. Visibility mode is whether or not motion layout controls the visibility of a given view. This will be important for a bug that I'm going to walk you through later, and motion progress as well. Next up is scale, translation, rotation, pivot, and elevation. This is all covered under the transform sub-element and lets you do crazy things like that. I cheated a little bit just there because I didn't just use the things that I had on screen. I used this other thing called keyframe set, which is something you can put in your transitions. What I'm doing here is I'm saying at frame position 33 out of 100, I want the square to translate 64 dp to the left. And later, I want it to translate to the right by 64 dp relative to its original path. This is starting to open up a lot of different interesting powers of animation, because previously with like Transition Manager, we specified kind of the start and kind of the end. We said fire and forget, and we hoped that they actually ran. This allows us to have extremely precise control of our animations. So there's that. The custom attribute sub-element, it can do a lot of different things, and I definitely didn't have time to put all of the different demos it can do, but just demoing text size, you can modify any property that takes a float, an integer, or a color through custom attribute. Doesn't matter what kind of view it is, as long as it has a getter and a setter. That's how motion layout works. It actually works through reflection right now, which is, oh, that's a little inefficient. I will show you why you shouldn't always use custom attribute in a future example. So there's motion is the last sub-element, and it's the most hard to understand, at least for me. So I'm going to go through the different properties and have examples for each one. Starting with transition easing. This is more or less just an interpolator, except you're specifying an interpolator for a specific view. This is the fine-grained control that motion layout can give you in terms of interpolators and views and animations. If you've ever run an animation that has an interpolator that is grouped across all views, this will save you. If you ever want to do path motion arc, you have two different options. You can either start horizontal or start vertical. What does that actually look like or do? So right now, I have a linear one, which is just no path motion arc, and I have a horizontal and a vertical. And basically what this is doing is, if there is both horizontal and vertical component to the motion, the path motion arc will try to make an arc in the direction that you just specified from the starting point. This is useful for a lot of the material design animations that Google's been trying to get us to do for years, and we keep pushing back and saying, no, this is really hard, especially with shared element transitions. Now this is kind of easy. This one is very much not documented or covered. There's a small bullet point in the release notes in one of the ConstraintLayout releases that specifies that this is meant to stagger which view gets animated first or last. So if you put 0, your view would be one of the very first to get animated in a motion scene. If you put 1, it would be one of the last ones to get animated. Next up is draw path. And what this basically is more of a debug thing than anything else. and as configured is just no draw path. Rectangles is where you're allowing the scene to draw a path with rectangles outlining the exact dimensions of the view along its path. And delta relative is showing you the delta relative of the path, like the horizontal and the vertical component of the motion. There are a couple other ones like path relative and some other things, but the important thing is this is useful when you want to debug the motion or path of a single view instead of every view on the screen. In other talks they've demonstrated if you say show paths on MotionLayout, it renders all paths. Well, what if you have 15 or 20 or 50 or 150 views that you're animating? Seeing all those paths is not useful information to you on the screen. Now we're going to get into the fun stuff, practical examples. First up is swiping items. Who here has ever tried to implement swiping in a RecyclerView where you swipe an item to the side and it doesn't always work the way you expect? Cool, this is going to be fun because it's easy. So I have this motion layout, and there's going to be two views in this. This motion layout is actually a RecyclerView view holder item, and there are two things in it. There's an archive button and a foreground. Now, you might think from what we've seen just far that we can just tell the foreground to be the target of a on-swipe gesture. This results in a really janky animation that I'm not going to show you. So instead, I'm just going to show you the right way to do it. We're going to put in another view called drag space. This is my name for it. And what this is going to do is going to take the touch action of the gesture and artificially move the foreground to the side or cover it up. The reason why is normally in a RecyclerView where you're doing this kind of thing, the foreground view is the entire width of the motion layout. If you're doing an on swipe of a view that spans the entire width or the entire height of the motion layout, on swipe doesn't know how to appropriately measure the distance of change because there is no distance of change, it's 0. So it's just going to go from progress of 1 to progress of 2 and look really bad. So actually how to write this in a motion scene file, we're going to first look at the on swipe. Normally we would write it this way, the wrong way, with a foreground. We're going to do it the right way where we just change the touch anchor to drag space. Next up is the two constraint sets, the start and end, which is pretty simple. Normally we might write this the wrong way with translation x from 0 and then -100 dp. Instead, what we're going to do is write a constraint set that has nothing in it because it just gets all of its layout attributes from the layout and constraints. And then the end constraint is going to have some layout sub-element constraints where it specifies a margin change. And this is what it looks like. I'm only adding blue on top of there so you can see the invisible space. You normally would just leave this transparent, or you could even use a space view so it takes up even less rendering power. Next up is a collapsing toolbar. This example is going to have absolutely nothing in the header whatsoever, so just imagine that this will be useful for further examples, but I want to start with this one. So we have a RecyclerView and just a view that is the header. It doesn't have anything in it, not even a frame layout. So the way this is going to work is, just like in the other on-swipe things, we're going to specify something that is going to move or change. In this, we're going to say that the header layout is the target, and it will be swiped up. So as you're scrolling up on the screen, this header layout is going to move or change size or do something. And it's going to be anchored by its bottom side. I'm going to get rid of that transition first, or collapse it down for a second, and we're going to look at the constraint sets. So the start constraint set has a header layout and the RecyclerView, an email list, for instance. And the header layout is going to have a fixed height of 128 dp. And now we're going to look at the end constraint. And we have a header layout with 80 dp height. Wait, where'd the constraints for the RecyclerView go? Don't we need that in the end state? Well, Recently there was a MotionLayout release that introduced derived constraint sets, and this is super useful for not having to rewrite or copy paste all over your app every single constraint of every single view in every single motion layout. So this is just pulling from start what the constraints are of the recycler view and putting it in the end state. Cool, so now we're going to make a collapsing toolbar with actually something in it. And in order to do that, we're going to use nested motion layout. So we're going to have a parent motion layout tell its child what its progress should be, according to the parent's gesture. So first, let's define the header motion layout. And this is what it's going to look like in the end state. We're going to have a collapsing header, and it's going to change text size. So in order to do that, I'm going to change the header layout from a view to a motion layout. And then I'm going to look at the motion scene file, and first collapse the transition, get away with it. And how can we go about scaling text? There was an example that I had before with custom attribute, right? So we could do that. Except this is a bad idea. Because of what I showed before, this could get really janky and not look smooth when it scales. Especially when you're trying to manipulate both the recycler view and motion layout all in one. What if you have lots of images on screen? You're putting up rendering power for something that doesn't need it. So a better way to do this is using the transform sub-element. I said I'd be coming back to this eventually. So using this, you can say scale x, scale y from 100% to 70%. That's how you specify that. And now you get the view smoothly operating. Looking back at the parent, I want to show you exactly how you get the progress of the parent down to the child. So if we look at the constraint for the header layout and its start, again have very much similar things, except there's this one new line that says property set motion progress. I said I'd be coming back to this later. Right now it's setting it to 0. So in the start state, the parent is saying to its child, hey, when I'm at my start, you will be 0. Now at the end state, again we have a header layout constraint, and again we have a motion progress property, and we're again saying from the parent, when I'm at my end state, you will be 1. So we are essentially passing the progress of the parent to the child, because the parent's progress will be going from 0 to 1 as the same exact time frame and scale that the child will be. So again, when it all comes together and you compile it and run it, it looks like that. Cool. So changing text in motion layout. So far I haven't manipulated the text very much, but here I have just a handler that's running in the background. You should never do this with post delay, but it's changing the actual text of the title view. And as you can see, it looks super weird. Why does it look weird? Well, I just highlighted the background with a background color, so you can actually see that the overall width is wrapping to the text view. And at the same time, you can't quite tell this for sure, but trust me, the pivot point of the scaling transition remains the same despite the text that's in the text view. Motion layout is not completely aware of all of its child views, especially text views. So if you're changing text inside of a motion view or motion layout, especially if you're doing translations between different languages and your text size can change, you should really keep this in mind. So how do we work around this? Well, right now we're wrapping content. If we change to match parent, the text view's size does still change in the animation, but that does not change relative to the size of the text. It only changes as the entire view is scaled. As a bonus, we can actually delete the constraints start and end from this view because motion layout is weird and doesn't need it when you set match parent to a constraint. It still works. Cool, so visibility. There's this very strange example that I have. It's not quite clear what it's intended to do, but essentially I have a handler running in the background that's trying and failing to set the visibility of that circle in the header from visibility gone to visibility visible. And it's failing to do this because MotionLayout is trying to maintain the visibility of this view. If you've started with MotionLayout already, you've probably run into this if you tried messing with visibility. So MotionLayout team has introduced this really cool handy flag, which I mentioned before, I would get back to, is visibility mode. And you can say visibility mode ignore, and then all of a sudden you can show and hide things at random or actually with purpose in your UX. I failed to think of a better example to come up with than that. So with the two values of visibility mode, they're ignore and normal. And normal is just the default for all views and all constraint sets. So if you have multiple constraint sets and you say visibility mode ignore in one of them, it won't matter unless you also say visibility mode ignore in the end or start constraint set as well. Because it will be like, oh, I'm ignoring it in this state, but I'm not ignoring it in this state. So haha, I'm gonna mess with your visibility again. Cool. Changing constraints programmatically. MotionLayout is just an extension of ConstraintLayout, and a lot of us, ever since 2017, when Robinhood made the blog post about how they were trying to do animations with ConstraintLayout, they were showing how you could programmatically say, make this constraint set and then apply to the constraint layout and use transition manager, begin delayed transition, and it would animate across the screen. Beautiful. MotionLayout, the way to do that is you obtain the current constraint set from MotionLayout, and then you say MotionLayout, you make your changes or whatever, and then you say MotionLayout update state with the state ID, so like start or end or whatever ID that you pulled it from, as well as the constraint set that you just modified, so you're passing it back in. So an example of this is I got tasked with building this photo grid where you have a 3x3 grid and you're supposed to be able to tap on any given view and it's supposed to essentially take over the screen, zoom in. Now, if I were not doing this programmatically and just motion scene files, I would have to maybe make 10 different constraint sets and lots of different transitions. This seems like a lot of work and I don't like working. So programmatically I can set the constraints of the zoomed in state for whatever view I just tapped on. I'm going to set its elevation to be 1 and also in the background make sure the elevation of all the other existing views is 0. And then I'm going to say update state. Right, and then the motion scene file that this correlates to is going to have 2 different states, and it's going to have grid and zoomed in, 2 states instead of 10, and a lot less work for me. And it looks like this, and it works perfectly. No shared element transitions, no nothing weird business. And I can also cancel animations, which is really important and hard to do in shared element transitions and other transition manager stuff. RecyclerView and MotionLayout placeholder. So this is a super fun one because it's been demoed by the ConstraintLayout team, John Hofford and Nicholas Roord, and their implementation is trying to use RecyclerView adapter, but it's not yet available, so we can't actually play around with it. So far, we've just seen demos. I just showed you how to programmatically manipulate constraint sets, so I'm just going to take that to the next level and do it with RecyclerView. So this is a demo of it actually running, and yeah. So when you tap on something, I'm finding the constraints of the view holder and setting the start state of the placeholder to whatever that view holder's constraints are. And then I can do this to any given view and do all kinds of manipulations. You can either pull the bitmap from it, you could remake the view yourself. There's lots of different methods to actually implement pushing the state of the view holder into the placeholder motion layout. Pick and choose which one is best for you. And the source code's already online, so you can play around with it if you want. Couple more practical examples. So there's wrapping height in MotionLayout header, which is a bug right now, where it does this weird thing where the header doesn't actually scroll or scale. It just changes from progress 1 to progress 0, and that's because it's not interpreting the scroll state correctly. Hopefully it'll be eventually fixed. It's currently at P1, so that's good. In the meantime, here's my workaround, which is weird. So I had this motion scene, and it's great. It's got just a layout height of wrap content for its expanded state and a layout height of fixed height, 80 dp, for its collapse state. So how am I working around this? I actually have this other state with a fixed height, and I'm calling it the start state. Now, this goes into a behavior of how MotionLayout interprets motion scene files. If I collapse all these transitions, you can see I now have 3. There's start, expanded, and collapsed. And I have a transition that goes from start to expanded. It takes 500 milliseconds, and it's using a flag called auto transition to move to it. It says animate to end. So as soon as this scene gets to the state of start, it will automatically try to move to end. And because this transition is at the top of the file, MotionLayout will load this file and try to run this transition first, and also put the motion scene in the start state first. This is important so that the scene is loaded, the layout runs, and then you get to this state where you can say on swipe normally from expanded to collapsed. This magically resolves the wrap height issue. There's a little bit more required. You need to programmatically state that after a MotionLayout transition, which is actually an extension function that I wrote, and I will show you that later, how that's written. Look at the start state, and does that match the start state that I'm looking for? Stop listening, stop all of the listeners, set the transition from expanded to collapsed, and make sure the progress is currently 0. This will allow the on-swipe listener to be able to catch up, and you'll be able to scroll normally. Now you get a wrapped height header. So I just use an auto transition, and auto transitions can be amazing. I made this really weird, cool hourglass thing that had absolutely no input from anyone from product or design anywhere in the world. It's not useful for anyone, but it's fun, and it shows off a lot of different auto transition things in Path Motion Arc. The bad thing is that auto transitions can fail, and actually they fail a lot. When there's too many auto transitions, one right after another, if you try to chain them, especially in a circular loop. If there's too short durations or 0 duration in an auto transition, it probably won't fire. The UI thread is too busy or blocked, or something else is going on, and just everyone's sad all the time and it fails. So use auto transitions sparingly. They're good on occasion for resolving some issues like the wrap header height bug. This is a practical examples section, but this is a very impractical thing that I decided to do, where I'm manipulating auto transitions to try to get reentrant and smooth transitions without having it seem like it's utterly stopping and changing its transition to something else. I haven't found a practical use for this exactly, basically turning on and off auto transition on all the transitions in the motion scene. Maybe you will find a practical use for this, or make a game out of it. I don't know. More practical, so debugging. You're constantly going to be asking yourself, what state am I in when you're in MotionLayout? You're going to have a start state, a current state, and an end state. And you can get all these properties at any given time from the MotionLayout. So if you have a reference to that, you're good. One way of debugging those different states is this specific thing. Show paths true is definitely something that other people have been showing as debugging, but motion debug show all actually shows you, renders out progress at the bottom of the motion layout, and it shows you, it's really tiny font, sorry, basically the current state and the progress of the current animation on your phones. Like as you're swiping, you can visually debug with that way. Another thing that you can use is build some extension functions, and I'll have these up on a GitHub repo later. This one, needs transition, is really great for when you're like, do I actually need to run this transition or like attempt this? And basically it just says, if you're moving, are we moving to the destination? If we're not moving, we definitely need a transition. If we're at the end state, did we get to the destination that we're talking about, or did we get to some other destination? And then this last one, unknown state, in my real code, I actually have this throwing an exception, and I haven't seen it get fired yet, so if anyone ever does, please tweet at me and maybe file a bug on the issue tracker, because that's weird. You might have noticed if you could have like super optical scan vision on that progress thing that was too small font before, you might have seen that it was saying unknown state before. MotionLayout, whenever a view is moving through a transition, its current state is -1. So I just say moving whenever I'm debugging. I had this little helper function to get the current resource name of the MotionLayout state. Those 3 different things: start, current, or end. You can also write an extension function for setting the transition listener. This allows you to observe the current state of the transition listener, maybe pass a completion method through it. I feel like some Kotlin KTX motion layout love is going to be handy and needed for motion layout. This last method down here at the bottom, it's already removed in beta 2. I only have it in here because every single example in this talk is in beta 1, and I'm holding off on beta 2 until they fix a weird scrolling bug in beta 2. So use beta 1, but also you'll have to write this weird line that says equals true always. So there's some limitations in practical areas. Some problems cannot be solved with derived constraints, and creating a large number of them is just strange sometimes. So I made this really cool puzzle app where you can do sliding tile puzzle with n factorial divided by 2 states. Might be a problem. 2 by 2 seems okay, but each required a handwritten constraint set. And this 2 by 2 board had 12 different states to iterate, so 12 constraint sets. If I had a 3 by 3 board, I'd suddenly have to write 181,000 constraint sets, and that's ridiculous. So Hoffer tweeted back at me, "Cool demo, dude," and they're gonna try to rework how motion layout works so they can do programmatic things like that, so you don't have to write everything by hand. It's actually partially in the works in beta 2, but so quickly, other practical examples. There's this really neat progress indicator. They've been demoing progress indicators in a couple different places, but haven't posted the code for it. There will be code for this, and basically it's just one scene with 2 states, start and end, and you're manipulating 4 different views. It's pretty easy to put together, and you can use it for all kinds of different things in your app. No more weird page indicator. Another thing is, I showed you guys swiping before, but you can also have automatically closing swipe items, because calling transition to start or transition to end in a motion layout is easy and simple. So this just works. All I'm doing is subscribing to clicks and swipe events, and making sure that I'm looking back in history to see if there was some other swipe event that happened, and make sure that I say transition to start for that other view holder. There's this one, which is just a super fun progress bar that just animates. Progress bars are strange, and animating them smoothly is weird, but motion layout makes it easy. This one I got a request on subreddit for making a tab layout with many nested scroll views. I had to do some Kotlin code in order to make this actually work together and have the progress emitted from the nested scroll views or view pager into the motion layout. So not the motion layout controlling it, but other things controlling it. In summary, why you should try motion layout: it reduces context switching, it makes some hard animations easier, it allows us to make much better animations in general, but it's still in beta, and I've had to go through a lot of pain of learning this. I hope you don't have to. I hope there's more materials, and debugging is a bit of trial and error. One last thing. I built this cool example that has absolutely everything I put together, and some more stuff. So this is that weird progress indicator, but even better, or progress bar switcher thing for an empty state. And this is everything at once with a RecyclerView and swiping. And also I'm doing image matrix manipulation while I'm doing constraint set manipulation on motion layout in order to get into that. And these are just different parts of my life. I went to that fountain, it was pretty cool. And yeah, I go skiing sometimes. And I have fun on roller coasters, and I also got keyboard presence detection working with motion layout, so I can observe keyboard and have motion layout respond to it. So I hope you love this talk, and I hope you learn a lot from it. And are there any questions? That's all.